Let's Science is brought to you by the Star Quest Production Network and is made possible by our many generous patrons. If you'd like to support the podcast, please visit sqpn.com/give.
3, 2, 1.
We live in a universe of scientific wonders.
Every day, scientists are inching towards breakthroughs which can change our lives.
We're playing our small part in sharing these wonders with you.
That's why today is a fine day for science.
So let's science.
So, Caroline, there are 2 types of COVID treatments that are in development right here in Australia. Over to you. Tell us all about them.
Yeah, so I guess this is kind of like some good COVID news. It's easy to talk about the doom and gloom of it, but there is a bit of hope with new treatments being developed. So we have our vaccines on the way to pretty much being well developed and being handed out all over the place, lots of different types of vaccines. But now some Australian scientists have two groups of researchers. I'm going to talk to you quickly about 2 different types of treatments. We've got scientists here in Queensland there's 2 groups, there's 2 different types of treatment for COVID. I'll just go through. The first one is scientists from QMIR Berghofer Medical Research Institute of Queensland have developed 2 types of drugs for the treatment of COVID-19. One is to prevent infection from the SARS-CoV-2 virus, and the other is to treat people who've already been infected and to prevent severe disease happening. The findings were published in the Journal of Nature Cell Discovery on May 24th, 2021. So this is very recent. In the journal, they mentioned that even though there are some drugs available to treat severe COVID-19 disease, such as remdesivir and other corticosteroids, there's still a high morbidity and mortality even when these kinds of drugs are used. Also, asymptomatic people are able to shed the virus over an extended duration and, they may be going around spreading the disease. Mass vaccinations take time and not everyone will respond well to the vaccine, or even some people don't want to take the vaccine for various reasons. So they're developing a therapeutic treatment which uses the mechanisms of infection by the virus in the cell as an additional tool to go along with vaccinations to help fight the virus and to prevent the spread in populations. The SARS-CoV-2 virus, okay, so we're getting into the biochemistry a little bit here.
It's all yours.
It uses an ACE2 cellular receptor, so it's a little protein that sits inside the cell membrane, and it's expressed or found in the cell membrane of the lung, the kidney, and gastrointestinal tract cells. And we know that with, bad COVID disease that you can be affected not just in the lungs, but, in all of these organs as well. So the ACE2 receptor protein has become the target of their research and the target of this therapy because it binds to the SARS-CoV-2 spike protein. And that's how it lets the virus into the cell and let it replicate and go on to cause disease. So it's kind of a lock and key mechanism. SARS-CoV-2 virus comes along to this receptor and the virus then unlocks the cell and it enters. One of the researchers, Professor Sudha Rao, said that they were able to develop the drugs after discovering that some people have a chemical tag which acts like a padlock to the ACE2 receptor. She says the tag can either keep the receptor locked or open, control infection. This means people who have the padlock-like tag on their ACE2 receptors will be less susceptible to SARS-CoV-2, and those without the tag are more vulnerable to the infection. Our drugs stop the tag being removed and also protect the untagged ACE2 receptors from being infected. So I had a little read of their paper and I just got out some of the very basic biochemistry of it, but and I just to explain how...
Is there such thing as basic biochemistry?
No. So it took me quite a bit to decipher. Lucky I have a little bit of a background, but it was very interesting. Their therapy uses a peptide. Do you want to know what a peptide is? So it's a short chain of amino acids between 2 and 50 amino acids linked together by peptide bonds. And then these peptides can go on to make proteins and long chains, and proteins are basically just long chains of amino acids. So I think everyone's probably familiar with the idea of a protein, but a peptide is just a very, very short chain of these amino acids. So for the SARS-CoV-2 virus to enter the cell, they found that there's the ACE2 protein, and then it's got a little protein next to it called LSD1, which is, they're calling it an epigenetic eraser enzyme. Now, when we're talking about epigenetics, we're talking about factors that will influence gene expression. So you can be exposed to something in the environment and it will cause the genes to be expressed or not expressed, something like that. So basically, binding of the virus, when we're talking about the binding of the COVID-2 virus, what LSD1 does, it causes the demethylation of ACE2. So what that does, picture the ACE2 protein sitting in the cell membrane. The LSD1 takes a methyl group off. Now, methyl group is a very tiny molecule that's attached to the protein. But when the methyl group or molecule is removed, the SARS-CoV-2 virus then is able to bind to the ACE2 protein. And the idea with the drugs is that this peptide will inhibit the function of the LSD1 protein, and it will reduce entry of the virus into your cell. So the peptide drug actually binds to the ACE2 protein, and they have the second drug that they've made works in the same way, but it works inside the cell. So one will work on the outside, one will work on the inside. And so they're saying one drug will act like a cloak around the cell and prevent the virus entering into a cell and by binding to the receptor. And the second drug prevents the virus replicating if it does get into the cell. And the first drug, by binding, it kind of cloaks the cell. So you get SARS-CoV-2 kind of going through the bloodstream looking for cells to bind to, but there'll be the peptide already bound to the cell and it can't see the receptors. So it's kind of hiding the cells that may express these receptors. So I thought that's really quite interesting thinking and interesting discovery to make. It's quite detailed and, a very cool, just another way of thinking of how Lino's making a very confused face.
You heard his brain.
I heard your brain.
No, it's like, when you said peptides, I think way back, Essendon Saga. What was peptides?
Oh, of course, the drug scandal.
It's a little group of amino acids. They would be using it to build up their muscles, like proteins, Yeah.
Right. Okay.
So we're talking about a very, very small chain here, and it just.
I was about to say.
Yeah. It's not anything to do with you're allowed to take it. It's even sports people will be allowed to take this one, and it will help to prevent a person getting the disease, and it will also help. So if your cells are infected, it will stop the disease. Will stop replication of the virus once it's in the cell.
Awesome.
So the research is conducted on COVID-19 patient blood and on human cells. And these COVID-19 patients were, people who've had the disease and, different variants of the disease and so on. And there's been testing done on hamsters. And the peptide.
Sorry, guys. Sorry.
It's okay. And then the peptide drugs are being used at the preclinical and clinical research at IDMIT in France with promising results, which is great. They found that the drug is non-toxic. It doesn't have side effects. It can be stored at room temperature, which is great because there's no issue with having to store at very cold temperatures or anything like that. And the next step now is to start clinical trials, and they're hoping to do that as soon as possible and hopefully to have this therapeutic drug available mid next year in 2022. You can imagine having such a treatment around, if say there's an outbreak like here in Melbourne, and there are people who need to be protected but they haven't been vaccinated, you can give them this drug and they'll be protected from the virus.
Awesome.
So I'll explain. There's one more which is really cool as well. Some Queensland researchers from Menzies Health Institute in Queensland at Griffith University, in conjunction with some researchers from the US, Research Institute, the City of Hope, they began research last April, and they've kind of designed a seek and destroy mission through their drugs. This is the kind of thing for patients who are already unwell with COVID-19, and they've developed a gene silencing RNA technology. So what happens is this attacks the virus genome directly. So this one goes straight for the DNA, like there's no chance.
Oh, wow.
It just stops the virus dead in its track. It cannot spread. So what they're doing is using nanoparticles that seeks out the virus within the lung cells through the bloodstream, and it goes and attacks the virus. Other body parts aren't harmed or affected with this technology. It's pretty much like they said, seek and destroy.
Seek and destroy, yes.
Wow.
Yeah.
Yes.
Cool.
Professor Macmillan, one of the researchers, explains that it's not a cure, but it's a therapy that can reduce the amount of virus in the lung by 99.9%, which is excellent.
Wow.
Amazing.
And they've designed this one for people who are, say, in ICU, really suffering, where vaccination is too late. So it can actually help people to stop dying if they've been treated soon enough. The virus can be destroyed in the body, and then the body can start to heal itself, and then, the person can recover. The great thing about this one is it works on all variants of the virus, as well as SARS and MERS, which belongs to the two beta coronaviruses that the SARS-CoV-2 virus belongs to. We talked about it probably quite a few episodes ago now.
A while ago, yes. Yeah.
Because it attacks specific region of the genome. So, it's such a great development. You can save a lot of people's lives with this. It's stable at 4 degrees, and it can be stored for 12 months at 4 degrees. So this is also another treatment that goes along, with vaccines as well. So, and they mentioned too, say, for example, you're in hotel quarantine and there are people infected, you can also take this. And if you've started to become infected, you can also get rid of the virus in your body. So for me, this is exciting, good news. We are making progress on the way to knocking this virus on the head. Hopefully they can get it out really soon and out to countries who are really suffering from the disease.
I was thinking, India at the moment.
That's
those poor people this would be a miracle for a country like India and some others that are struggling right now.
There are many countries who are really suffering with this. This is very exciting, and I was really happy to be able to bring such good news. I know that there are other kinds of therapies being developed all around the world, but since these are being developed here in Australia, I wanted to highlight them. Really good.
Can I throw a couple of questions your way? They're simple questions, don't worry. So, So the first one, which protects a person's cell from being recognized by the virus. I hope I'm saying that correctly.
Yes, yes.
But would that be in lieu of a vaccine, or would you need a vaccine as well? So could you take one or the other, or?
No, you would. It's probably best to be vaccinated, because then you would have to keep kind of taking the therapy. The therapy is there as another form of protecting, something to protect you. If you're going into an environment where the SARS-CoV-2 around, you can have this and you will be protected, while you're taking the therapy. So, and the other one, you would say if person is in ICU, they would need to take an injection once for every day for 5 days. So I think they're still working out how exactly to use them as well. But the best protection is to be vaccinated, because your body will recognize the virus in your body and it will attack it, and the immune response will be triggered, and, your body will fight it off. But this is another protection on top of that, something to use with it.
Yeah, and the second therapy you mentioned, clearly but if you weren't vaccinated and you got ill, like you said, in hotel quarantine or something, it would seek and destroy. Was it 99% of the virus?
99.9%. So yeah, it would get rid of the virus in your body. Yeah, whether you've got a lot of it or a little. So it's great. Yeah.
And so the other question I wanted to ask, so you talked about the duration of that first therapy. So it's not one that you could just take and you're protected forever. But the other thing I was going to ask was, how is it administered? Are we talking about a pill or it's about an IV, intravenous?
Actually, I didn't see.
Has that been?
They're still running clinical trials on that one, but a peptide, I guess you would have to ingest. I mean, well, not necessarily, because you could be given it as an injection as well. I didn't get to see exactly how they're going to administer that one, but yeah, at least I just thought the functioning of the actual peptide was really interesting with that one.
So, you guys, I was thinking, well, what about when the time comes? Probably, sadly, very long ago. Hoping not too long. Is when we go overseas. So we get with vaccinations. How long will that vaccination last for? You know what I mean?
Yeah.
So let's say you get vaccinated today, and then you're planning to go overseas in about 3 or 4 months. Is that vaccination still inside you, Caroline? And you don't have to take it off? Yeah.
So from when I was doing the research on these vaccinations, as far as I know, they last. This is still very early, and actually, we're not really 100% sure. They know that definitely you have to have a booster shot every year. So it's going to become like the flu shot where you need to take it every year. They were saying it can last about 6 months, but I'm imagining that maybe it would last longer. I'm not sure. Yeah, so you definitely need to have booster shots with this.
Gotcha.
I think you could probably go and do an antibody test to see the level of antibodies in your body and to see if you've got the right level of protection after being vaccinated. I think if you've got an antibody load after having the disease, that does go down over time. So, but the vaccination, it lasts longer than that. So, yeah.
It's like, when you want to go overseas, you get the hepatitis A shot, right?
Yeah.
B shot now, and now you have to take a vaccination shot to protect yourself for when you go overseas.
Mm-hmm.
So I understand. Yeah, it's just going to be interesting when you want to go overseas. Then you have to time it. In a sense, I take a shot there.
I would. I'd definitely make sure I'm up to date with my COVID-19 and whatever else you have to take. It's very wise to
depending
do
on
that.
where you go. Yeah, there's recommendations. So if you go to your GP and say, "Hey, I'm going to this country," they'll say, "Well, we recommend that you are vaccinated for this, this, and this." Yeah, that's right.
When I went to Thailand, I had to get vaccinated with something. Even when I went to Peru for quite a while ago now, but I think there was a yellow fever vaccination that they recommended to take as well. So, yeah, it can be region specific, but I think COVID-19 now is kind of world specific, Earth specific. So it's best to be up to date with that. Yeah.
Exactly.
Yeah. Exactly. Well, let's move from this planet, Caroline, to another heavenly body. So this week, guys, in Melbourne, we were very, very fortunate to not have a cloudy sky because we got to witness all of it in totality, a beautiful lunar eclipse. Now, it had a different kind of name, but Caroline, can you tell us what you saw this week?
Yeah, so there was the, excuse me, we did have a full lunar eclipse, the total lunar eclipse that happened, was it Thursday night? Wednesday night.
Yeah, Wednesday night. Yeah.
Yes, it started from I think the eclipse started about 8:30 p.m.
Mm-hmm.
And thank you to the moon and the planet Earth for doing it at a decent time and not 2 a.m. or something.
2 a.m. was really good in the morning.
Last time, I think a few years ago, there was an eclipse and it was like 2 a.m. in the morning. Yeah, I looked outside and went back to bed, but yes. But Lino, I don't know. Lino, you and I were talking about if it was going to be cloudy or not, because usually when we want to see something, it always ends up cloudy.
It's always cloudy.
But
it's a Melbourne rarity to have something happening in the night sky with no clouds, at a decent time that you could actually witness.
It wasn't windy. It was beautiful, crisp, clear night. It
was just cold, but that you can handle.
It was cold, but I rugged up. I had my PJs on. I had a big coat. I had my nice Ugg boots on and a beanie, and so I was all ready. It started about 8:30 when the shadow started. It went till about 9:30 or so, but we had a total eclipse, and we could see the moon went really dark red. And
awesome.
it was a spectacular sight to see the Earth's shadow completely cover the moon. It was just amazing. I got my children out, I let them stay up late, and we watched it together. I took some photos, which actually turned out not too bad. I tried to get my telescope out, but unfortunately I bought a very heavy base and I couldn't get it out. So I have learnt next time to get my small one out, which I'm now going to put out there to be permanent, the same as my large telescope. And because it's still very good for viewing the moon. I'm kind of kicking myself, but that's okay. I'll be ready next time. And so I took some beautiful photos just with my camera. And it was amazing. Such a beautiful thing to see. I'm so glad we got to see it.
So that was the last time we had something?
To see it, Lino?
Oh, well, we had, I missed the other one. Was it a lunar eclipse? No, it was an eclipse of, was it Caroline? Saturn?
The conjunction.
Conjunction.
That was last year.
And I thought to myself, and I went, "Oh, I've got to wait another 60 years for this."
Well, you won't. Good news. You only have to wait 5 years for the next one.
Exactly. For this one, I went.
For the next
if I miss this, I'll wait 5 years. That's cool. Yeah, that's okay.
We'll have mission parishes set up by then as well, so you can. Yeah.
So we can all watch it together.
We all can watch together.
But definitely, if this happens in the next 5 years, I definitely highly recommend going out and really experiencing, just stopping life for a while, going outside, being with nature, being with the natural occurrences of the sky, and it just makes you think, because the shadow, it goes over the moon and you just think, wow, Earth must be so much bigger than the moon to be able to fully eclipse it. And you just start, whenever you look at space, you look up at the night sky, you start pondering, and it just brings out that in you, and it's so peaceful and calming. So apart from just the scientific side, there's the human side. We can't help being connected to nature and God's creation. So
awesome.
Yeah,
it's beautiful.
And one last bit of moon news. So I was every now and then I check out space.com, which has a great they just have great articles on things that are currently happening in around the world of space and space science. And they have an article which is all about the Japanese Space Agency, who I'm just falling in love. I just love.
Yeah, pretty cool.
Let me tell you why I love the Japanese Space Agency so much. They are. We talked about was it the Hayabusa probe?
Hayabusa 2,
yeah, Hayabusa 2, and the mini rovers and shooting asteroids with
dropping off a sample to Earth and moving on
and
to
then
the
keeping
next
going.
thing.
Yeah.
Wow.
I just love these compact, modular kind of designs that they do. So they're sending. They are going to be sending a lander to the moon next year, and it's called Hakuto R. And it's basically it's got all these different modules that people can attach cameras and sensors and all kinds of things to, which is amazing in itself. And in the link that I'll share, there's a great video showing how the landing system works. It's pretty much an advertising video, because then it's like, and it's got landing legs to minimize the shock and your devices will be powered by batteries with large solar panels and all that. I just love all this. It's great. Yeah. And it shows how it flies to the moon and the landing, whatever. However, what is really cool are two things. One is, and Lino, you and I were having a good laugh about this the other day, is the Toyota Land Rover Mars rover, which is so cool.
So
yeah. So Toyota is making basically a
space rover. It's a space rover.
Yeah, for humans to drive around in.
I was going to say Land Rover, but like I said to you guys, I just take it.
Yeah, it has.
Take it. You can't do that.
However, I want to see two astronauts jumping in front of it going, oh, what a feeling. Toyota.
They don't have to jump so high, don't they?
They just have a little bit, maybe.
Yeah. But the other really, really cool thing, and this is what really got my attention, is that next year they'll also send, as part of that mission, a baseball-sized rover, like a mini rover, to the moon. And it's basically a ball, and it does open up and it's got some basic sensors to measure moon dust,
Yes.
which apparently can be corrosive to certain
it's
things.
quite
So they
sticky.
yeah. So they want to measure it, analyze it, and things like that. But this thing, I just want everyone to imagine, like, it looks a bit like BB-8 in some kinds of ways.
Yes, it really
I just
does.
want to see this thing rolling around on the moon. And in fact, they need to paint it BB-8 colors.
They should.
Oh, wow.
It's a must.
Yeah, Disney and Star Wars isn't on that one, guys. I
Yeah.
can tell you they'll
Yeah.
be going in that one. Yep.
Yeah, and it's just a little transformable lunar robot. So it's
Transformable. That is the word, guys.
It transforms, yeah. And that is so Japanese cartoon.
That
Yeah.
is
kind
so
of,
Japanese cartoon.
I love it. I love it so
Love
much.
how they think outside the box. It's
definitely.
amazing.
It's so smart. Yeah, so there are some great images of the concept of it. There are some things that are unknown about it, but there are some images on the website, the link that I'm going to share in our show notes, showing it in ball mode and then in transformed mode where it
So
opens up
good.
and the instrument pops out. Yeah, so
Love it.
yeah,
Love it.
I really want to see live footage of this when
Oh
it's
my
doing its
goodness,
thing.
yes.
I just want to see a little ball, like a little
Yeah.
baseball rolling around on
Yeah.
the surface of the moon.
I think the moon is going to be crowded very soon. Everybody's going there.
I was
It's
to
the
say,
place
guys.
to be.
Yeah.
Yeah.
Lots of rovers, lots of
A lot of
people.
robots.
Yeah.
Yeah.
Hope it's not so busy as a Monash. But anyway, that's beside the point.
Oh, it may.
Yeah.
Yeah.
Oh, wow.
And the last thing I've got is just some really cheeky news about some moon landings. So we know that there's some rivalry between the different
Yes, you sent us this.
corporations that are trying to send
You love
things
it.
to the moon. So Blue Origin, who lost the bid for the human landing system to SpaceX, they said the following: the human landing system program needs competition, not the delay of starting over. The national team has an open architecture, deep experience, massive self-funded investments, and a safe, low-risk design to return to the moon. Let's go, Artemis. To which Elon Musk simply responded, for the low price of...
Exactly. That was so funny.
So he kind of trolled it. So he's making a comment on how a lot of these proposed systems are super expensive. We're talking billions of dollars. And the human landing system that Blue Origin, as cool as it is basically, it's disposable, it's not reusable, it's and very, very expensive. Whereas Starship is meant to actually be a very low cost option because it's reusable, because the technology is there, it's quite advanced, and also because it gives you the potential for a massive payload that you can take to the moon, not just a bunch of people and some small equipment. So that's the science one. Anything else we want to add, or I think we're good science wise?
Well, we could talk so much. So much has been happening, but we'll leave it there, I think. Hey,
So we will bring you more science
Yes.
very soon.
It's hard to choose actually what to speak about every week. I really have to think of what stands out and then think, that's what I'm going to talk about.
There's so much to cover.
Very well.
Yeah. But everyone who's listening as well, please, we've had a few people send us topics and we'd like to look at those in the future. So if you would like to send us a science topic, please do, and Caroline will do all our homework anyway.
Leave it to me.
Caroline's got it.
Let's Science is brought to you by StarQuest Media and is a fortnightly podcast that brings you the scientific wonders of our universe from a distinctly Catholic point of view. For more from Caroline, Lindsay, and friends, listen to the StarQuest show, Catholics of Oz. Find links from today's show at sqpn.com/science and find the Catholics of Oz at sqpn.com/Oz. Be sure to follow the show in Apple Podcasts, Google Play, wherever you can find podcasts, or on the SQPN YouTube channel. The generous donations of our patrons at sqpn.com/give make it possible for us to continue Let's Science and all the shows at StarQuest, which makes our nonprofit mission possible. You can join them by visiting sqpn.com/give. Join us next time for more scientific wonders, and thank you for listening to Let's Science on StarQuest.